Today we will be learning about Singleton Pattern. What is basically a Singleton Pattern? And before learning any kind of a pattern, we must understand what is the need of using a Singleton Pattern. Okay, having a Singleton Pattern there for you doesn't mean that you should always include or anyways compulsorily include the Singleton Pattern in your application. Okay, so first there has to be certain requirements. Okay, so what is the requirements and when you should use the Singleton Pattern? Okay, so when there is a need in your application that you need to have only and only one object of your class, and you want it only one throughout the life cycle of an application till your application ends. Okay, so Singleton Pattern basically enforces the clients to use a class or to use your class in a way that the client would be able to instantiate or get only a one object when they ask you for an instance of that Singleton class. Okay, so that was a Singleton Pattern means that only one object creation should be allowed. Okay, and the third point is very important, which is an enforcement. Okay, if you do not enforce your class, or means you do not apply some technique in your class and that allows maybe a user to create n number of objects, then your purpose is defeated. So you have to put some technique to enforce the client to use your class in a way such that they are only able to get only one object. Okay, so we will see. And what could be the basic examples when the Singleton Pattern or the Singleton class is required? So let's say um, you have an application that speaks to a database. Okay, so might be you need only one class or one database connection class that holds the connection to your database. I mean, only one class suffices. Okay, you do not need to have the multiple objects or thousand objects for each connections. Okay, a single class can do. You can encapsulate that in a single class, and you want the clients to have only a one database connection throughout an app, throughout the application. In your tier, only one object could be created. Or for example, a logger class in which all the logs, your traces, your build, your debug logs, your information logs, all the logs are being logged to a file or to any output stream. So in that case, also you need a one logger class. Okay, and the reason being also because creating multiple instances of that logger class might be not so much an efficient way to log the logs. Okay, so the efficiency is also one of the reason, and to avoid certain bugs also. Okay, so let's see. Let's have one dummy class which we want to make it as a singleton. So like I have, let's say, manager. It's just a name. Okay, this is my class, and let's have, let's say, the constructor, and I have the copy constructor here. Okay, and let me define the constructor here. Let's say manager constructor, and here I define the copy constructor here. Let me put some logs here. Copy constructor. You can have an assignment operator also as well here, and you may wish to also maybe in some cases have that, but in a singleton class there is particularly no need because you can't have two objects, so the assignment operator, I mean, would not be any useful thing here. Okay, and so So if I wish to create a object of this class, so I would go it like this: manager, let's say m1 equals to new manager. So this new would be firstly allocating the buffer, the memory, on a heap, and then we'll be calling the constructor. Okay. Similarly, if I want to make a second object, let's say m2 is equal to new manager. So, and let me print out the addresses of this as well. Okay. So let me have m1, and here std cout m2 equals to all right. So let me run this small thing, and so we'll succeeded, and we can see the two objects are created here, and these are the two different objects that is been created. These are the addresses. So if I want to make this class as a singleton, I should not allow my users or the clients of this class to directly call upon a new with my type. Okay, because if one can call a new on my type, then the client would be able to create as many instances of my class. So the way out is I declare this into a private. Okay, so I have my constructor and my copy constructor. So both the type of constructor as a private, so that my client would not be able to call new. And why? Because the constructors are in private, so it can't be accessed. So if you see, it's now giving an error calling a private constructor of class manager. So if I build it, this would gonna fail. Okay, so my purpose is achieved, that my clients are not able to use the new operator directly on my type, but I need to give some interface to my clients for them to get the object of a manager. Okay. So that interface would be static, because I want my client to use that interface with my class name. So let's declare that in a public. Okay, so it could be static manager star. Let me give it a name at get instance. Okay, and let me implement it here. So it's manager pointer, manager class name, the method name, and here I can return new manager here. Okay, so I have created an instance here. So sorry, an API here, which is a static API, and here I have used this. I have called new because it's being a member of this class, so I can call new here on my type here. Okay, so I can just replace it as manager get instance, and here also I can use manager get instance. All right, so if I run it now, it would succeed in compiling, and I would see that that the object two, again the two objects are created. It's this one, and second is this one. You see the addresses are different. Okay, so again I need one more way in which I can enforce so that only one instance is written. Okay, so what I can do is that I can take a variable. Okay, again a static variable, because it's a static class. It's not a let's say it's not a method, but it's a class method. Okay, so note this pointer is being passed here. Okay, so if any variable I want to use, I could use the static variable here. Okay, so let me take that variable in a private, because I do not want to expose it to my client. So let me take it at static manager and instance. Okay, so this variable would be would be holding an instance of an manager, the object of a manager class. So let me first initialize it. So let me initialize it as manager star manager instance equals to null pr. Okay, so here mark that we are initializing it. It is private, but yeah, you cannot further initial assign it, but here you can of course initialize it to a null pointer. And here what we can check is that we can apply in a check if instance equals to null pointer, which would be the case the first time only. And here if it's in then what you have to do, you have to just assign this instance instance variable, a new instance of your class. Okay, so now the next time the get instance would be called, it would not be a null pointer, and here you need to return the instance variable, which is the object you created only one time when your instance static variable was a null, which you initialize it at the very beginning of your program. Okay, so now you see the m1 and m2 would be the same object that I would be getting here. Okay, so anytime I would be calling the get instance, I would be getting the one and only the one object being created. So let me rerun it, and you see that I got a same object here. I again rerun it. Yeah, so again the same object, m1 and m2 are both same. Okay, so this way we can implement our singleton class. Mark that the constructors should be in a private, so that the client cannot apply a new operator directly on your data type or on your class to get as many as instances. So this is the way of enforcing. And of course copy constructor also has to be in private, because once you have an object, you cannot copy construct in another object. So you both have to put that into the private. But there is one more problem. What about the thread safety? Okay, so I'll show you about this thread safety. It's not a thread safe basically. So currently there is only one thread of execution. So what I mean by thread is the flow of execution. Okay, so as we know that our applications generally have multiple threads, in this program we have only a main thread here. Okay, so this get instance method is serialized in a way that only one thread is accessing it. So get instance will get its access in a serialized form. But this might not be a case if two threads are parallelly contending for get instance. For example, you call this get instance here in main, but you call this get instance in a separate thread which might be running parallelly. So there could be a contention, or there would be a race condition in which, let's say, your thread A has come here and recognize instance equal to null pointer, and your thread A is here and it's about to initialize the manager, or you construct the manager object, and before it executes this line, the thread goes to sleep. Okay, and your next thread comes, which is a thread B. It still sees the instance as a null. Okay, because this instance variable has not been updated by thread A, so it's still a null pointer. And so when thread B comes, and since it's a static method, the instance is a static variable, it will find it still as a null, and the thread B will create this instance here. And now what happened is that thread A wakes up or gets the computation or a CPU slice. It will again instantiate a second object. Okay, and there could be possibly two instances of manager working. So there could be a race condition in which the instance variable is not fully updated by any of the thread, and two threads happen to be inside this if clause, and they are creating a two instances of manager. So I'll explain you practically. So let's say I have one function here, which is, let's say, void create manager. I created this just a function, and let me put this here. Okay, and let's say I invoke one thread. I'll create one a thread here. Okay, so or let me create a thread here. Let me include thread header. Yeah, and let me here create std thread, let's say t. I pass the create manager function here. Okay, and so this would be a second block of an execution, which would get a, you can say, a new branch of execution, which would be in parallel to this main. Okay, and here I would be joining it. Okay, so this join function is just to wait for you can say wait for this create manager to finish before the main or the complete application gets over. So this join is for that only. Okay, so let's run it and let's see. So we'll succeed it. So there is no race condition here. So since there is no race condition here, so the two thread happens to the create to get a same instance of a manager class. So let's try to manipulate, and let's try to have one simulate the race condition here, or simulate a sleep of a thread. So for instance, here I want one of the thread to sleep, so that the another thread gets a chance to uh, to get this to operate on this, or to execute this method. So let me put some kind of a sleep here. So let's say this thread sleep for I need to include a chrono header as well, to include, I have a chrono here, and here I can make the thread to sleep for, say, 1 millisecond. Okay, so here there would be two threads that would be executing. One is the main thread here, and second would be this thread that I'm creating here, and it is accessing the get manager in this thread. So the two thread would be contending, and I want one of the thread to sleep, so that the next thread gets the chance and would see this instance still as a null pointer, and two objects would be created. So you will be having a different addresses here if two different objects are created. So let me rub it. This is just to simulate thread sleep. Another threads gets the CPU slice. Okay, so if I run it now, great. So you see here that M1, which is basically in a main thread, it created a manager object, and the second thread, which is this thread T, it is also getting a get instance, but here you see a different object has been created. This is because of the race condition, that two threads sees the value of instance as null, and so the two instances being created. So we need to avoid it. So the way to avoid this thing is to use the locking mechanism. So what we have to maintain the integrity. So we will use the lock here. So lock the critical section. So basically this is the critical section. What's the critical section is that which is you can have some shared resources there, because instance is a static variable, and so it's a shared kind of a variable or a shared resource, you can say. So you need to lock this critical section, because race condition could happen, and before returning you could unlock the section, which is, you can say, as a critical section. Okay, so when you are locking this critical section, only one thread is allowed to see the value of instance, and hence if it's null it would be creating it. So once you define this as a critical section, no two threads are allowed to execute inside this critical section. So we use a locks, which is being given by C++. So we have a mutex here. So I just have the mutex header here, and of course I would be using it as a static. I create one, you could say here, static std mutex. I give it as m1. Okay, and let me initialize it as well. So std mutex it is manager m1. Cool. So now I would be locking this critical section using m1.lock, and here before I return I would be unlocking this m1.unlock. Okay, so you will see that only one instance would be created, and the addresses of this would both be same, because the same object would be written. So whosoever, whether a main thread or this thread T, whoever would be accessing it, only one will be allowed to enter this section. Only one thread would be seeing this value of this instance, whatever it is, and it will be creating it and initializing or assigning this instance some value. So once the thread unlocks the critical section, another thread gets the chance, and it will see that the instance value is now there. It will just skip this block and it would return the already created object which is being assigned to this instance variable. Perfect. So let's run it and see. So I just missed it, and now if you run it, you will see that only a single object is there. Whosoever would be using my API get instance would be getting only one object in thread conditions also. Okay, so this singleton becomes a thread safe singleton class. Okay, so now thread safety you have taken care by having this lock. But guys, there is one you can say performance hit. Not performance hit I can say, but yes, I mean you are paying a price in a sense. Say, let's say one thread would be creating the instance, okay, but each and every thread or each and every client, or you can say any process who, or a thread who would be accessing this get instance, would anyhow would be locking this critical section again and again, which might not be needed if the instance variable is already created. So the locking of this mutex and unlocking of this mutex takes the CPU resources, and which are quite heavy. Okay, so when large number of threads use your get instance API, so the contention will become very slow, or and getting this object of singleton object would become a little bit slow, right? Because of the unnecessary lock and unlock while your instance is already being created. Okay, so why not, before taking a lock, you check whether the instance is there or not. Okay, because once the instance is not there, then only you need this section to be protected, or and when the instance is not there, then only you need a log, else you do not need such kind of a lock here. Okay, so I could put this entire critical section again in a check instance equal to null ptr, and I can completely put my entire logic inside this thing. So this is called as a double checking of this double checking of this instance variable. Okay, so I would be only needing lock, or you, let's say your one of the thread comes and it's just acquire a lock to the critical section. It sees the value as null pointer, it instantiate the object, fills up the instance variable, and just unlock that critical section and return an instance. So now the next time, had this instance checking had not been there, then what would have happened is that the second thread would also acquire this log, third thread will also acquire this log, and unnecessary would be checking this and unlocking this. So this kind of check is not necessary once your instance is being formed. Okay, so you put another check. So if the instance has been already being created here, you do not need to acquire any kind of a lock here, you just return the value. So it becomes a little bit faster when n number of threads or a large number of threads accesses your class. Okay, so again, if you run it, you see that the same objects has been created every time. Okay, so this is called as a double checking locking mechanism, in which you improve over the performance of your get instance API. So I hope, friends, you enjoyed this video. You get to learn so much of learning. Please write in the comment section what is your learnings and how you like this video. I hope this has been a great learning experience to you all. And just to repeat it, Singleton pattern, only one object throughout your applications. You have to enforce the interfaces by making it as a private. You have to take care about thread safety in case you are creating it on heap. Okay, so there is another method of creating a singleton class in which when you do not want your object to be created on heap. So there is another way of creating that, and for that also no locking would be required. But in case you are creating it on heap just like this using a new operator, so you will be needing a mutex and double locking mechanism like this to maintain the thread safety of your singleton class. Okay, so this is the way you can create it. I have just shown you. I hope you enjoyed the video. Stay tuned for my more videos learning on design patterns, C++, and more tech stuffs. Thank you so much. See you next time. Bye bye.